Okay, let's dive right into this explainer. We're looking at what is essentially an incredible, high-stakes engineering heist that India's pulling off to power its future. I mean, this is a multi-generational, incredibly complex physics puzzle that was designed decades ago, and it's all about one massive goal: securing absolute energy independence.
To understand how they're actually doing this, we're going to follow Dr. Homi Bhabha's original blueprint. We'll start with India's unique nuclear dilemma, map out stages 1, 2, and 3, take a hard look at a massive radiation hurdle they have to overcome, and finally, look at exactly where India's nuclear presence stands today.
So, Part 1, India's unique nuclear dilemma. The core problem here is pretty stark. India is sitting on a staggering 320,000 tons of thorium, but only about 40,000 tons of uranium. Think about that ratio. If they just rely on uranium like the rest of the world does, their long-term nuclear ambitions are severely capped. But if they can somehow figure out how to use that massive mountain of thorium, well, they could theoretically power the entire country for centuries.
But of course, there is a major catch. Natural thorium, specifically thorium-232, is what physicists call a fertile material, meaning it lacks a fissile component. It absolutely cannot spark or sustain a chain reaction on its own. To actually be useful, it needs to be placed inside a reactor and bombarded with neutrons until it transforms into uranium-233. And U-233? That is an absolutely excellent fissile material that burns beautifully as reactor fuel.
So the crucial point here is mastering a piece of tech known as the breeder reactor, which honestly sounds a bit like science fiction, but a breeder reactor actually has the capacity to produce more fissile material than it consumes while it's generating power. By using materials with a really high breeding ratio, you can essentially create your own future fuel right out of that dormant thorium.
And this brings us to Dr. Bhabha's ingenious three-stage process. It acts as a step-by-step strategy to slowly transition the entire country off scarce uranium and over to a fully thorium-based grid. Because you can't use thorium directly, you need initial reactors running on something else just to produce those neutrons needed to irradiate the thorium in the first place.
Right, moving on to Part 2, Stage 1, Heavy Water.
In this very first stage, India builds pressurized heavy water reactors, or PHWRs. They chose this very specific design because it runs on natural uranium, totally bypassing the massively expensive 3 to 4% enrichment process that light water reactors need. Plus, it uses heavy water as a moderator and coolant, which India already produces in huge surplus. Now, while these reactors are producing vital electricity for the grid, they are secretly performing a second, absolutely critical job. They're quietly converting fertile uranium-238 into plutonium-239.
Which sets us up perfectly for Part 3, Stage 2, Fast Breeders.
To handle that newly created material, scientists use a truly fascinating concept, a washing machine for plutonium. You see, the plutonium recovered from Stage 1 is full of other isotopes like plutonium-240 and 241. Scientists literally refer to this as dirty plutonium. But fast breeder reactors, FBRs, can actually run on this dirty mixture. And as they run, the uranium-238 blanket inside the reactor breeds pure, unadulterated plutonium-239. So the reactor literally acts as a washing machine, taking in dirty plutonium and generating clean, pure fuel.
So here is how this whole process builds across the second stage. First, you run your FBRs with that plutonium and uranium mix. Second, you run them long enough just to accumulate a massive stockpile of fissile material. Then, once you have enough plutonium to sustain your fast power reactors, you initiate step 3. You swap out part of the uranium blanket for a blanket of thorium. And finally, that fertile thorium begins absorbing neutrons, breeding our ultimate prize, uranium-233.
Part 4, Stage 3, Thorium Power.
Stage 3 is the ultimate target of this whole endeavor. It involves running advanced thermal breeder reactors, and potentially fast breeders or molten salt reactors, entirely on that newly bred uranium-233 and the incredibly abundant thorium reserves. Because the breeding ratio of uranium-233 is just exceptionally high, this stage effectively guarantees India a sustained, self-feeding loop of nuclear power production. We're talking energy that could last for centuries.
Okay, Part 5, the radiation hurdle.
Because obviously every great heist has a complication, this is the specific problem with uranium-233 fuel. When you are breeding it from thorium, a totally unavoidable side reaction occurs that creates an isotope called uranium-232. As that decays, it produces an isotope of thallium, specifically thallium-208. And thallium-208 decays rapidly, blasting out 2.6 mega-electron volts of hard gamma radiation. This makes handling the newly bred fuel, reprocessing it, and refabricating it impossibly dangerous for human hands.
Just looking at the spontaneous disintegration path going straight down to stable lead, you hit a severe gamma radiation spike. Because of this extremely hostile chain, managing the fuel demands excessive care. To actually survive this hurdle, Indian engineers must rely almost entirely on highly advanced remote handling and complete 100% automation for fuel fabrication.
Which brings us to part 6, India's nuclear present. Where does all this stand today? Well, current data proves that Stage 1 isn't just some abstract theory. It is actively powering the grid right now. Looking at numbers from the Nuclear Power Corporation of India, there are currently 24 thermal reactors operating across the country, all belonging to Stage 1. You've got major hubs like Tarpur, Rajasthan, and Kudankulam really doing the heavy lifting here.
Together, these 24 operating Stage 1 power plants are already generating a massive 8,180 megawatts of electrical capacity for the nation. They are producing vital electricity every single day while quietly, steadily generating the plutonium needed for the next phase.
And Stage 2? It's officially becoming a reality. A massive 500-megawatt prototype fast breeder reactor, or PFBR, has been constructed down in Tamil Nadu and is expected to become critical soon. The literal second that reactor fully comes online, India's giant washing machine for plutonium begins spinning, moving the country definitively into the second phase of this multi-generational plan.
Which leaves us with this final, truly fascinating question to ponder. With Stage 1 actively powering the grid and Stage 2 about to go critical, we are watching an unprecedented scientific gamble play out in real time. If they can successfully automate past those intense gamma radiation hurdles, is India about to unlock centuries of limitless energy and completely rewrite the global energy map? It's a staggering engineering journey and definitely one we'll be keeping a close eye on. Thanks for joining me on this explainer.